today, and then we have first the Meet the Reader session, and I think I hope we have some more audience, but well, yeah, because Mr. Domin Lee, and then he has some really excellent the lecture, and he has a great the career, so it's a kind of rare opportunity to hear such a presentation. So well, I want to introduce. Okay. I want to introduce, Mr. Domini, and then now and then he is in Sony kind of game company, and previously he worked at TikTok and then DreamWorks, and well he will talk about very interesting some kind of special effect in movies and animations. Okay, Domin, can you start?
Yeah, sure. Let me first share my screen. Mm, Can you see my screen?
Yes.
Oh, yeah. So title for today's presentation is Practical Usage of VFX Technique, Present and Future. And I have a lot to cover, so I'm gonna just dive right in. So like Dr. Kim just mentioned, I'm going to be starting at Sony's Insomniac Games. They're known for a Spider-Man game series. But before that, I worked at TikTok for about 4 years. And before TikTok, I worked at DreamWorks for about 14 and a half years. Okay. So before we jump into the main content, I want to give a quick overview of today's presentation. First, I'm going to briefly talk about different areas of computer science. As mentioned in my as mentioned in my bio, I actually studied computer science in my grad school and then worked in animation industry for over 14 years. But even now, I still meet people who ask me like where I learned to paint, just because I worked on animated movies. That always makes me smile because it's a great reminder that not everyone realizes how much computer science goes into making animation. And since you will be learning Python during this camp, I want to take a moment to show you like how programming and computer science plays a critical role in computer graphics. And from there, I will walk you through a general computer graphics pipeline and share Cloud's work I did at DreamWorks. Then I will talk about how I took what I learned from making animated movies and applied it to big data visualization. And finally, I will try to connect all the dots and explain how those experiences led me to my role as head of interactive engineering at TikTok, where I worked on AR effects. And if we have time, we will have a few minutes of Q&A at the end. So feel free to send any questions to the chat. So before we get into the details, I want to highlight how broad computer science really is and where computer graphics fits in. As you can see in this diagram, computer graphics is one of many areas of computer science, but it's deeply connected to many other areas. For example, algorithm and data structures help render images efficiently. AI and machine learning are used to generate a realistic motion or upscale texture automatically nowadays. And computer systems and architecture, especially GPUs nowadays, are what makes real-time rendering possible. And software engineering is critical for building the tools artists rely on every day. And human-computer interaction, HCI, helps us design better creative interfaces. And distributed systems and cloud computing make large-scale rendering and collaboration possible. And even areas like cybersecurity and database system matter because studios need to protect their assets and manage massive amounts of data. So while computer graphics may look like just one bubble in the middle here, It draws from almost every parts of computer science. So now that you have that bigger picture, let's zoom in on the computer graphics, especially a computer graphics production pipeline. So here's a final image of Shrek holding Puss in Boots, and there's a donkey looking at Shrek. And in order to create this image, many teams needed to collaborate. And once you have a script and it's greenlit by the studio, you start the production. And it starts with a story department. A story department creates storyboards. It's a process of translating the script and the director's vision into pictures like what you see here. It's basically creating a visual representation of the script. And as storyboards are being created, art department starts to define the look and feel of the film. Like in this painting from Shrek, you start deciding the visual style of the film or animation in this case. And then character designer visualize and create the look of individual characters like Puss in Boots here. They usually work from description given to them by the director. These might include notes on a character's personality as well as physical traits. And once the design is done, a modeler works closely with art director or production designer to make sure that all models conform to the intended design and visual style of the film. And after character models are approved, riggers or character TDs create skeletons, bone structures, and controls which define movement of a character. And the model and rig you see here is for a previous department. It's a low resolution model and rig so that it runs faster than the production model. A previous artist then take those models and creates a sequence of shots that convey the story through character blocking, camera positioning, rough animation of both characters and camera. We still call this department previs, but if you look at more recent previs from like high-end studio, it looks much more polished because of a recent advancement of computers and game engine technology. After shots are blocked out by previous department, animators take the fully rigged character and breathe life into those characters. Animators are basically actors and actresses in a movie. As animators are working on animating the characters, surfacing departments enhances the appearance of characters, props, and environments according to the visual style of the film. Surfacing artist paints digitally using various texturing software. And when a shot requires effects like rain, effects animator gets involved by creating different layers for effects element. For example, if there's a shot Shrek standing in the rain, we create rain sliding down Shrek's skin, and then splashes when rain hits Shrek, and then overall rain for the environment. We create these layers and combine them to make the final effects. So effects departments are responsible for adding natural phenomenon like rain, fire, water, dust, and destruction. We also work with a visual effects supervisor to determine the most effective approach to solving various production challenges and problems, like the cloud pipeline that I'm going to discuss later. And then lighting gathers all the information coming from the upstream departments and light and render the scene to make the final image. And there are other departments like character effects that simulates hair and clothes, or matte painting department that handles a set extension, or crowd department that handles simulating and animating crowds. So to go from a storyboard to a fully rendered scene, it takes a lot of resource and money. Again, like making animated movies takes a lot of time and a lot of people as well. So on average, it takes about 3 to 4 years and involves 300 to 400 artists working together. And it's a huge effort, and it's not cheap either. So while we are always trying to create cool visuals that you haven't seen and we haven't done before, we also spend a lot of time figuring out how to make things faster and more efficient, which software engineers often do. Next, I will show you an example of one of the effects that I worked on at DreamWorks and how solving a technical challenge helped bring that animation to life. But first, what is effects? When people ask me these questions, I tell them it's anything that moves within a shot that's not related to character. So effects in a movie is things like explosion, water, rain, fire. But today we are going to look at cloud. Creating 3D, realistic 3D clouds has been studied extensively in various formats. Despite a long history of research, it's still pretty challenging to produce large scenes with cloud, especially when characters have to fly through and interact with the clouds. And DreamWorks are pretty well known for constructing highly complex sequences with clouds. As you will see next, our previous cloud workflow worked pretty well when it was first developed, and even for the next few movies, but it needed to be updated as technology improved and demand for the bigger and larger cloudscape became much higher than before. So like I worked on like many effects at DreamWorks, but if I have to pick one thing that I'm most proud of, it's cloud. I was in charge of developing and maintaining cloud pipelines since 2011. Uh, and as I mentioned, DreamWorks movies have many flying sequences. So having an efficient pipeline for rendering cloud is something that we deeply cared about. And my work won Tech Award back in 2020. And also complexity of our cloud sequences is far greater than other animation studios. So for today, I'm going to like briefly talk about the cloud pipeline that I developed. But if you want to know more about the details, I presented a course title, How to Train Your Cloud at SIGGRAPH Asia conference back in 2020. So you can go to that conference website if you want to know more details about the course. Mm. So before I talk about the pipeline that I worked on, the previous pipeline looked something like this. 4 departments had to be involved in creating each shot. So once modeling is done, a cloud model were set rest by layout. Effects department then processed the geometry into a volumetric cloud by first converting cloud geometry into something called a sign distance field and then applying different sets of noise. Effects also rendered 3 layers that were needed to composite the final image. And then lighting brought those layers into their compositing setup and graded into their renders along with matte painting for the background. And as you can see in this chart, a large portion of cloud work was under effects. And after it was developed for Puss in Boots, DreamWorks continued using the same pipeline in Rise of the Guardians, How to Train Your Dragon 2, and Croods. And then How to Train Your Dragon Hidden World happened. This is the third series, third How to Train Your Dragon in the series. The appetite for high quality volumetric cloud for the film significantly exceeded previous shows as clouds was considered to be a part of the storytelling. So there was a like huge, immense desire from layout effects and lighting to develop a more efficient workflow for designing, simulating, rendering 3D clouds. Basically, with a film demanding complexity that is far greater than the previous films, our cloud pipeline had to be redesigned. And with the following three motivations. So the first is meet the demand of more sophisticated storytelling. And the second one is it had to be modernized for a ray tracer, but also for a new data flow between modeling, set dressing, effects, lighting, rendering, and compositing. And last, by designing a new data flow, we wanted to unify the fragmented lighting workflow so that it looks better. So let me finish this video to, let me wait for this video to finish. Okay. And more importantly, as mentioned before, a huge chunk of cloud work was done in effects department. And that made a cloud sequence to be very, very expensive. So this is what the new cloud pipeline looks like now. It organized the data flow to be coherent from the outset in layout. It matches the composition set by layout more accurately. Although FX did a lot of early development, we were mostly removed from modeling, surfacing, rendering of the clouds. So lighting was able to light and render and seamlessly integrate the clouds to the final image. So to briefly give you an idea of what was developed, whenever people ask me how to make a great looking cloud, I always tell them making CG cloud is 50% modeling and 50% lighting. So let's first take a look at how we modeled clouds. So we made different types of clouds based on many references, but also studied how clouds are formed. I'm sure many of you learned in elementary school, but basically clouds are formed because they rise with heat from the earth. Density increases at lower temperature. Temperature decreases over altitude. Dense region makes a round shape as they rise. Wind direction varies over altitude. So atmospheric turbulence distorts the cloud's shape, and light region tends to diffuse like fog. So we modeled all these characteristics to our cloud model, and then we moved on to the lighting. Rendering a nice looking cloud is not trivial because they are made up of tiny water droplets. And as you can see in this picture, it's really tiny even compared to the raindrop. And why that's important? Because they are made up of tiny water droplets, when light ray hits those tiny water droplets, it does a bunch of interesting things. Some rays are reflected, some rays are refracted, and some bounce inside and exit on the other side. And we modeled this behavior. We have to model this behavior in our renderer in order to get nice looking cloud. Since R&D at DreamWorks wrote our own ray tracer, we were able to ask them to split out each light bounces so we can access them later as layers or AOVs. And this is illustrating different light bounces as the light penetrates the cloud. So after rebuilding the cloud pipeline from the ground up in both modeling and lighting, we were able to render clouds with much higher fidelity and complexity. So that was like really a quick and short version of Cloud course I gave at SIGGRAPH Asia. And Cloud Pipe 3.0 is what DreamWorks still uses for all their movies. And these are some of the making of video. So like Cloud Pipe, FX team often handles various challenges like developing a brand new pipeline to match the production needs. And we also do lots of data processing in order to render images for our movies. And we are now gonna take a look at what kind of data and at what scale we handle data in effects. Here's a sequence of shots from How to Train Your Dragon 2. And this was one of the biggest effects from the movie. So to render the water shot like what you just saw, we had to simulate around 400 million points, and that's more than the population of the US. Right? So it's a lot of points that you need to track. And And in order to render those 400 million points, we have to process the data by deleting points that are not needed, like what you see here. We are basically creating a bounding box and keeping only the points that we want. And to further reduce the number of points, we calculate additional information like a visibility from the camera. And here's another example where we apply a smoothing filter to delete even more points that are not visible to the camera. And we do these processing on those points so we can render them later in the pipeline. And once the cleaning process is done, we have to turn those points into a mesh. And this process takes a long time. And to make the process more efficient, well, we developed a way to parallelize a process of turning points into mesh. And after going through these processes, we can finally render the shots with water, right? And this is 400 million points. And nowadays, people simulate well over 1 billion points. So to review the process that we went through in order to render a sequence of water shots, we first simulate, isolate the data that we need, and then process and do some optimization, and then finally render them. And once again, so we simulate the data that we need. In this case is water, and we isolate the data that we want from the camera, and we further process the data, and then we optimize the data so we can fit it into our renderer, and then we render the data to visualize. And 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 this, if you think about how data visualization work, it's pretty similar. In order to visualize data, you first need to collect the data, and you do some cleanup of the data, you process it, and if you need to optimize it, then you optimize it, and then you finally visualize. So about like 7 or 8 years ago, I thought like why not take visual effects techniques from making movies and apply it to data visualization. And at the time, I thought, and I still believe in this, in order to like truly understand the data, in order to tell the story within each data, you really need to do a good job of visualizing the data. So let me explain what I mean by this first, and then we will look at one example. So here's a data set called Anscombe's quartet. As you can see here, it's made up of 4 data. And these 4 data shares the same mean, variance, and XY correlation. But if you plot these data into a graph, you can clearly see how different they are. So why visualization is important? Because it lets you discover pattern within the data. And by understanding the data better, you can consume the data more easily. So the data becomes more actionable. And lastly, you can tell the story of the data better. And the number on the right doesn't mean anything. But if you map each number to a color and visualize it, it becomes a masterpiece that everyone knows. So that's the power of visualization. So now that we know why data visualization is important, let's take a look at one example. It's from a non-profit organization called SODA-V that I'm part of. And the project that I'm going to share is about refugee. When you do data visualization, I think the most challenging part of data visualization is probably data collection. It's really tough to find good, clean data. But for refugee, there were plenty of data that I could use, which also meant there were lots of visualization that were already done by a lot of data scientists and analysts like this or something like this. And here's another one that I could easily found by Googling it. And there were a ton of infographics like what you see here. But I wanted to use visual effects techniques that I learned by making animated movies to visualize the data. I was certain that it will help to tell a better story. So I first tried to make 3D model of Earth and I started plotting refugee migration data on the Earth model. And then I added some additional info on the right, how many refugee each country had in 1 month. And this is from 2012 to 2017. And then I added animation. So it shows the migration path and refugee numbers on the right. After seeing this video, I felt the numbers on the right was tough to understand or digest. How many is 20,000 people? Like to me, like it felt the number 20,000 was just a number. So I started to think about how can we give like more meaning to a number and landed on an idea of using one of the widely used VFX technique. And it's crowd simulation. So refugee using crowd simulation. And this is what 20,000 people look like. I chose 20,000 because that's how many people applied for asylum back in January of 2017. And after visualizing it in this format using crowd simulation technique, I thought it conveyed the weight of the number much better than just putting the number on the screen. Okay. And then next, I started to look into why people became refugee and decided to use something called rigid body dynamics. Uh, it's a technique often used for creating destruction in movies. And here is a result with rigid body simulation. I try to convey some of the reason why people become refugee through objects like you see here. Okay. So after creating those like those clips, I I then made 2-minute shorts using like different compositing techniques that I learned, and I'm gonna play that video now. Right. So besides the example that you just saw, you can find more videos by going to Sodabi website on YouTube if you are curious. Okay, so far we looked at CG pipeline and cloud pipeline, and then went over how the data processing and creating effects help to visualize big data. But like, what does it have to do with AR effects or working at a tech company like TikTok? As mentioned earlier, effects team does a lot of things, and one of those is system and tool development, as well as writing shaders. And leveraging these skills, I was able to create AR effects when I was at DreamWorks. So let's first take a look at AR project that I worked on along with a few other people at DreamWorks. So AR project that I'm gonna talk about is Trolls AR app that was released back in 2017. But in order to talk about the project, I need to briefly talk about how the project got started. It was first started with a bi-weekly coffee chat with a small group of people who were interested in exploring VR and AR space. Whenever we had a little downtime between movies at DreamWorks, we worked together to create a few VR experiences like Trolls 360 Video, Voltron VR, and Dragonflight VR, an interactive design character, a dragon character. And these were all prototypes that we built to test out different ideas on how to make VR more immersive. And then Apple introduced ARKit back in 2017. And after the announcement, we switched our focus to AR and continued to test different ideas. And around that time, Trolls Holiday Special was supposed to be aired on TV, and decided to make a Trolls AR app. So initial idea was to convert the opening sequence from the holiday special into an AR experience, which is playing on the left. So the first question was how to handle cuts and transition in AR, and we thought about using like portals, but settled on the table flip mechanics, which was first uh, introduced by Nintendo a long time ago. So this is the initial flip test, and we thought the test was promising. You will see this, yeah, okay, and opened lots of opportunity to be creative, like building a set underneath and revealing it when it flips over. So we started planning and setting goals for the project, and these goals were a must for us. Again, this was back in 2017 when ARKit was first announced. We first wanted to match the level of fidelity in the holiday special that was aired on TV. And when we showed the flip test to the marketing, they really got excited and asked to make an app that runs on like all devices that supports ARKit, which made our job even more challenging. We also wanted to make the app that is more engaging than just watching the animation in AR. We wanted audiences to be active during the experience rather than passive. And last goal was to have more than 2 characters. So to achieve the same aesthetic or fidelity that was in the TV special, we just brought in the production model of Poppy that you see here, and this is the result. Uh, First, like the Poppy looked horrible compared to what you see in TV, and it also made our phone really lag just with just a few props. So we quickly realized that we have to optimize a bunch of things in order to achieve our goals. The very first thing that we looked at was reducing polygonal counts or a number of triangles. We were able to drastically reduce the amount of polycounts, as you can see here, and this was done by a modeler. And then there was a hair. Every troll character has full of hair. At DreamWorks, we have something called a guide hair for simulation, and I took those guide hairs into something called Houdini and created these polygonal strips with vertex color, which is indicated in the center here. And here's another example. And this is another tool I wrote inside Houdini for generating something called LODs. It stands for levels of details. It's a technique that's widely used inside the game engine. And this was used in Dragonflight VR project, but we also used it on Trolls AR project to process environmental assets. And this is just showing how it maintains UV as you go in and out of different LODs. And, uh, and after developing those optimization, this is a proof of concept version that we put together. We weren't like still happy with how everything was shading, but we thought animation was getting transferred properly and other assets were being processed correctly. So we were pretty happy. So we started looking into adding more characters and interaction so users don't just stand in one place and watch. We really wanted to create experience where you get to engage with the experience. So the first thing that we came up with is since we know where the user who's holding the phone is, we use that information to trigger snow. As you can see, when you get close to the sphere, it triggers a snow to fall. Right? So after we test this idea, we made sure that it's gonna work in the actual app. We employed it into like a few other setups as well. And then we spent a lot of time refining the shader and added more characters like branch that you will see pretty soon. Yep. And then once the stage flips, you will see additional characters like Beaky and Mr. Dinkle. And we also added some animated environmental assets. Now let me wait until the stage flips. Yep. After that, we continue to refine by fixing bugs and adding more interactions and characters as well. We also did lots of profiling and optimization. Like remember that we wanted to make sure that our app can run on all devices that supports ARKit. So we made sure it runs consistently at 60 frames per second. We looked at CPU usage as well as memory usage, which was really high because of high resolution textures that we were using. But for the final app, we ended up reducing the resolution considerably in order to reduce the memory size. It did use lots of energy, which is expected for AR app. So we didn't. There wasn't anything we can do to improve. And we looked at GPU usage as well. We did more profiling on the game engine side. So in summary, the entire project took about 7 weeks from concept to the final product. We were able to make it run on all devices that supported ARKit at the time. And these tools were used for the project. This is just one example of AR effects that I worked on at DreamWorks. So the tools were Unity, Xcode. We shared assets through Google Drive. And these are some of the test devices. So we had only three testing devices and three Windows PC to work on the experience, and then only one MacBook Pro in order to publish the app. Yeah, so this is just like one simple example of AR effects, but at TikTok, my team was responsible for creating AR effects that cover much broader technology. So next, we will look at how TikTok AR effects work. But let me first finish, wait until the video finishes. Okay. So before I left TikTok at the end of last month, my team made lots of AR effects that you see on TikTok videos. But we also worked on a AR effects creation platform called Effect House, which let you publish your own AR effects on TikTok. To help you better understand what that means, let me first play a promotional video that we released along with a beta version of Effect House. Yeah, so Effects House is a powerful AR tool that makes it easy to create, publish, and share high quality augmented effects for TikTok, made with both beginner and advanced designers and developers in mind. Effect House empowers creator to build interactive experiences for TikTok users around the world. And it was released back in 2023 as a beta software. And it's been like amazing to see the impact that the platform is creating, as you can see in this slide. We created TikTok Effects House to like spark creativity and help people tell their stories in fun, engaging ways, and using the latest in AR technology. So whether like it's adding a little like magic to a moment or making something like totally unexpected, effects plays a big role in how content comes to life. So let's take a look at like how AR effects actually work on TikTok today. So in order to create AR effects, this is a framework that we use. As you can see here, there is three major blocks that camera input goes through before we have an output video. And input is whenever you shoot a video through TikTok app. And there are many computer scientists and engineers working on each block. But today I want to focus on rendering and VFX because that's what my team focused on. And I want to explain how working at DreamWorks over 14 years helped me prepare to do my job at TikTok. But let me first go through a few computer vision algorithm that TikTok rely on to make AR effects. So here are a few. So Landmark AR utilize a feature-based algorithm or deep learning approach to for landmark detection and recognition. These algorithms identify and analyze visual features such as points, lines, or shapes to locate a landmark in real-time video feed. And we also utilize something called a SLAM, simultaneous localization and mapping. And it's a core technology in robotics and autonomous navigation, which enables robots to create maps of unknown environments while simultaneously determining their location within those maps. So we use SLAM technology to put things in 3D space. We also rely heavily on pose detection to map 3D character or create additional effects like what you see here. We also utilize human segmentation to create interesting effects, as well as object segmentation. Saliency segmentation algorithm are computer vision techniques that identify and separate visually salient regions or objects within an image. So it's able to distinguish important areas from the background, making it easier to analyze and understand the image. And using AI is becoming a hot topic these days. And TikTok is also a huge, TikTok also has a huge team working on generative AI. But here are some of our old AI effects that's been released over the years. And we are also constantly looking into improving scene understanding, like what you see here. And we've been building additional capability that you can easily find in game engines like position-based dynamics and using Euler integration for particle simulation or solver. So what's really impressive is that all these advanced algorithm like face and body tracking, scene understanding, and gesture recognition that you saw have to run in real time, right on your phone, and not just on high-end devices, but across a huge range of hardware globally. That means the tech behind it isn't just advanced, it has to be incredibly efficient and lightweight, making all of this work smoothly on TikTok app, which serves over 1.6 billion user worldwide, is a massive engineering challenge, but it's what makes the magic of AR effects possible at scale. So let's go back to this slide before we wrap up. As you just saw, AR effects really sits at the intersection of art and technology. It all starts with a simple video input from the creator and then moves through these three major stages before producing the final output. Each stage requires highly skilled computer scientists, engineers, and artists to build the assets, write the code, and make everything work together. And studying computer science and working in animation really prepared me for this. It gave me a deep understanding of how computer graphics work and also taught me to think about efficiency across the entire pipeline, which turned out to be critical when developing AR effects for TikTok. So we covered a lot in a very short amount of time, but before I wrap up, I want to say I hope this talk gave you a sense of how learning to code or studying computer science can lead to some really fun and unexpected opportunities. For me, it led to working on animated movies at DreamWorks, creating AR effects at TikTok, and now I'm about to start a new adventure at Sony, working on the next Spider-Man game for PlayStation 5. So I will end with one of my favorite quotes, something that has inspired me throughout my journey. This quote is from John Lasseter. And it really speaks to me. Blending art and technology to create meaningful experiences has been my passion since the beginning of my career. So if you are someone who's interested in both art and tech, I hope today's talk gave you a glimpse of many exciting paths you can explore in the future. So yeah, thank you.
Thank you so much. Yeah, so maybe some of you may feel it's a little bit too fast, and then maybe you need something else to understand, but that's fine. So, well, if you have any questions, and then you can ask. So maybe some basic things or something not really related to this in today's presentation. So whatever. So it's a kind of rare opportunity again to talk to then level experts in this field. Okay.
Um, so you said that you majored in computer science, correct?
Yep.
Okay, so I know a lot of your presentation was about like visual and all the pipelining and stuff. So how was that transition from doing like coding computer science to switching to kind of the more art visual? How was that for you? How was that transition?
Yeah. So like I studied at so I did my undergrad in Korea, and then I came to the US to continue my study at Ohio State. So I went there to do computer mining. And then I was sitting in a lab doing my homework. And the person sitting next to me was doing his homework. But when he finished coding and hit compile, his codes became image. And that's when I first found out about computer graphics. So I started pretty late in the field of computer graphics. So right after I learned about computer graphics from the person sitting right next to me. I asked him what class he was taking first. So I took that class right away in the next semester, and then I start to explore different classes in the computer graphics. And at the same time, I spoke to a few people in art department. Art department also has computer graphics majors. So I talked to a few of those people and then started taking some of their classes. So I kept expanding uh, the knowledge base in computer graphics when I was in grad school. And while I was in my grad school, Pixar came to recruit some of the technical people, but also have a little bit of artistic talent. And I was able to get an interview with Pixar. And I started an internship after passing the interview. So that really kickstarted my career in this field. But for the transition, it wasn't easy at first. So I had to take a lot of classes outside of my major. That meant spending a lot more hours compared to people studying just their own major. But but I had to do it because I really enjoyed learning about computer graphics, and it was something that I was passionate about. So yeah, it just like whenever we hire a new people, new junior level developer or artist at DreamWorks, it's much easier to hire who has artistic talent but doesn't have a lot of technical skill. They join the studio and they can adapt much easier than who are more technical but doesn't have artistic talent. Those are the people who really struggles. So I think I just didn't know the field that existed. Uh, and after I knew this field existed, I was really quick to absorb all the new knowledge and able to adapt and continue my journey through this career. Yeah.
Okay, so some other questions? So, are you interested in what kind of, the work environment, he has? Mm. So it's gonna be a little bit different from some normal tech companies, maybe. Mm.
Oh, work environment at TikTok?
TikTok remarks and then, yeah, such a thing.
DreamWorks is a pretty like family-oriented company, so their work-life balance is really good. And I didn't really appreciate too much about it until I joined TikTok. TikTok's all the tech company tends to be like super competitive because a lot of like really good, really smart people, they go there to show their capability. I'm not saying that DreamWorks doesn't have a lot of those smart people, but tech company tends to attract a lot of highly skilled software engineers, and they tends to be very, very competitive in terms of creating new features and trying to advance in their careers by developing more and more features compared to their peers. And I was managing a pretty like sizable team, and I had about 40 people when it was at peak. So within those 40 people, I saw like firsthand how different people were trying to compete against each other, which I didn't really saw at DreamWorks. At DreamWorks, everything was more open and geared towards sharing your knowledge so that people next to you can succeed as well. But I guess I have to say, tech company is pretty different. And it's not just TikTok that is that way. I spoke to a few people working in tech company, and all the tech company tends to be the same way. And I think it's just the nature of the pace that they're working at. So they have to release a lot of features, and they get instant feedback from their user. So they have to navigate through what they're developing really quickly. They have to be super agile in terms of what they're doing, what they're developing. So just coming from their work, they have to be competitive, I think. But if you compare that to DreamWorks, you make a movie that kids watches, and you have a specific deadline that you have to hit. So there's a very specific schedule that you have to meet, and as long as you can meet those schedule, then there's no rush for you to be in. So yeah, in terms of like work environment, I think like you can't beat what DreamWorks offers. But if you want to learn like a cutting edge technology that is widely used, that serves billions of users, then tech company might offer you a really good opportunity to learn new skills.
Yeah, so the student and maybe yeah, you need to think about such the issue. So different companies and different the field, and then the work environment is different, and their value system is different. So depending on what you want to do in the future, so maybe not just money and then not just some kind of reputations, and maybe you need to think about what you really want to do. So among you and then, is there any student who really want to study computer science and then in the future you want to have some kind of career in computer science? So how many of you have such the plan?
I'm planning on doing data science, not computer science.
Okay, so it's just similar data science and the computer science. And then there are lots of the intersection. So how about others?
There's one question that just came in. So if I could start my career over, is there anything I would do differently? So yeah, I think it's related to what I mentioned earlier. So I knew about computer graphics really late. So if I could start my career over, I wish I had learned about computer graphics much sooner. Like when I first joined DreamWorks, I was pretty good at creating effects, but whenever I showed my work to like a director or my boss, I couldn't really get like why they were giving me some of the feedback that they were describing. And that was because I didn't know about like a movie making. So after a few years working at DreamWorks, I took a few classes at UCLA. UCLA has a certificate course, and I took a directing certificate course. And after I took a few classes about movie making, that's when I fully understood, like whenever a director asks for certain things, why they're asking me to make those changes. So if I had known about computer graphics, if I could have been exposed much sooner about this entertainment field, I think I could have adapted much sooner and creating much more, much, yeah, much better quality of work, maybe. Yeah. And then there's one more question. Did you study something related to your current work in college, or did you take a different path to get there? Oh, yeah, I think I answered it. So I studied computer science, not knowing that I'm going to be working in entertainment industry, but actually studying computer science actually helped later in my career. So, and compared to other effects artist or developer, like I think my career path is pretty similar to other effects artists. Like I showed, effects department tends to work on both technical and artistic things during production. So within effects team, most of the people that I worked with has had computer science degree. Most of them had masters, and a couple people had PhDs. But like most people had masters and below in computer science. I don't think. Oh, and we had a couple people who majored in art, and but they were very, very technical at the same time. So in order to work in effects, expectation is you have to be technical, but also artistic. But because software has become so good, uh, like being technical is not too critical in terms of getting effects position, but it used to be like very important.
I think that is a very interesting point. So these days, and then we have generative AI, and then even in visual art, and then generative AI is throwing lots of fantastic things, right? So how do you anticipate in the future? So how the generative AI gonna affect this the animation or visual art field?
Yeah, it's tough to say at the current state, but because uh, like if you like know how production like animation gets made, you have to be able to art direct what's been generated. So if you look at the video that's generated by Sora or like a Google's a new video model, once the video is generated, what happens during production is when you show that video, director would comment on certain things, and they would most likely want to change a few things within the video. And the current state of generative AI, you're not able to art direct what's being generated. And if you can art direct what's being what can be generated, then I can see some of the position get replaced by AI, but until that flexibility can happen, I don't think movie making can be replaced by AI completely. But I do see some of the effect in like concept art. Like even in TikTok, I often work with a design team who creates a simple 3D assets or 2D painting. And when I left TikTok, a lot of those people were getting replaced by AI. And that's like because of like how efficient AI can generate large amount of paintings. So like uh, there's there's not a huge need for having like tens of multiple concept artists who paints 2D painting. So rather than that, you just have one person and they who is a really good painter, and they ask them to use AI to create a large amount of painting that previously weren't possible. So like some of those fields will definitely get impacted by AI, but in terms of like creating an entire movie using I don't think that's going to be possible anytime soon. And when I say soon, it might be like within after 5 years, people might be just putting in script and then creating movies. But even yeah, it's tough to say. If you ask any director to just put in their script and be happy with what gets generated, I don't think any director will be satisfied. So.
Okay.
Oh, and the other thing is the reason that I am excited about going into the game industry is game industry has to be run in real time. So Gen AI relies heavily on uh, running on the GPU, and because it requires a huge amount of GPU power, I don't think creating interactive game makes sense in terms of if you think about how much you have to invest and how much money you can get back when people play game using Gen AI, it just doesn't make sense for the foreseeable future. So I think interactive game has a long way to go before AI can replace this industry. So yeah, game industry might be a good industry to look at if you are concerned about AI. And I see another question. Was it hard to work at TikTok since everything moves so fast there? And what were some of the challenges you experienced? Uh, so in terms of adjusting to the pace, uh, it was uh, it was challenging at first, but I got used to it pretty quickly. And you have to get used to it in order to survive. So I guess I wouldn't say it was hard, but it it was it was unexpected. I was expecting a similar approach in terms of creating effects, but their approach was very different. So, for example, uh, like if you work in entertainment industry, like a movie and animation, everything is driven by like a filmmaker. So if you are working in the animation field, animator has a huge say in how things gets made. So if you are developing a pipeline, or if you're developing a new renderer, then like a research scientist or software engineer, they have to rely heavily on animator or artist to develop their features. But if you join a tech company, then software engineers, uh, they are the one who's driving the most of the things. So when I first joined TikTok, we were developing avatar system. So you customize your own avatar, and your video feed can drive the animation on your avatar. So we were developing this new capability, and I joined one of the meeting, and it was to review some of the asset that you can place on your avatar. So it was like a look of like a hat or glasses, and then the software engineer was commenting on the design, which never happens at movie industry because designers owns the look of the classes. So if you, even if you want to comment on it as a software engineer, you're not allowed, I guess. But at the tech company, because software engineers are driving the feature, they can comment on even the design concept. So that was pretty like shocking at first, but once you get used to it, uh, it gives you a lot of like a freedom because as a engineering team, you get to decide a lot of stuff. So you can make decision quickly on the spot and then drive the project the way you want. And then what were some of the challenges you experienced? Uh, yeah, so the challenges, I guess it has to be the pace. Like when my team was supporting like a lot of different product at TikTok, at one point my team was supporting 17 different project or a team in in the company. So if you think about uh, 17 supporting 17 different team, then it's almost like creating 17 different apps or 17 different short films. And that was the schedule was pretty crazy at first. And I was working with like Apple, Samsung, and also creating effects for our uh, own team at the same time. So yeah, so just the pace of the team that was working, that was pretty challenging. And yeah, what else? Yeah, oh, I guess. And I worked, even when I was at DreamWorks, I was doing a lot of I was developing a lot of technical features. But when I joined TikTok, I got to experience what it's like to be navigating inside a huge repository. Effect House that I mentioned, uh, it has a lot of capability that like what you saw. So the code repository is like massive. And in order to navigate through those repository, it was very challenging, but also interesting experience. Yeah. Okay. So I just got another question. Was there a project you worked on that was really memorable or special to you?
Mhm.
Yeah, in terms of like animation, there are so many, but like I got interested in animation because after watching a movie called Incredibles, it's one of Pixar's animation, and the director for Incredible is somebody named Brad Bird. And when I interned at Pixar, I worked on a movie called Ratatouille, and the director for that film is also Brad Bird. So, and it was also my first film that I participated in, and I worked on cloth and hair. I was in a simulation team. So after working on simulating cloth and hair, I showed my work to the director, Brad Bird, and that was amazing. Just sitting inside the same room with Brad
Hmm.
Bird was amazing experience. And, and my first film at DreamWorks was Kung Fu Panda, and I really enjoyed the film as well. And then at yeah, yeah, there was like my team was focusing on improving the rendering capability and the fidelity of our render engine, and also improving the capability of Effect House platform, and also creating the efficient pipeline in order to create uh, like diverse effects that you can see on TikTok. So there are so many effects that we created, but Yeah, I guess the like most memorable project has to be the project that I worked on just before I left. I was working on AI GAN. So GAN is a generative adversarial network. Uh, it let you train using input and output. And if you specify the area after training a model and apply that model to the area, then you can match whatever that's within that area to the model that you trained. So we trained a model that takes very simple circles and turned that into high fidelity fire. And we completed that technology right before I left. And then we found out that it was accepted to SIGGRAPH. So it will be presented at SIGGRAPH this year, which is happening in August. So yeah, that's probably the most memorable and special project at TikTok. And here's so the question is, were the workers a lot younger at TikTok? Yeah, definitely. So most of my team member, they were in their like mid to late 20s. And compared to that, like people at DreamWorks, most of the people were my age. So late 40s, and some are like even early 50s. And there were a few people who were younger, like, but they weren't like late 20s. So maybe early 30s. And most of the people that's working at DreamWorks that I worked with, they're still there. So a lot of people have been with the DreamWorks well over 20 years. And compare that to TikTok, a lot of people in my team, they just joined TikTok. So like most people that I worked with, they've been with TikTok between 1 to 3 years. Uh, yeah, so they were young, so they come with a lot of energy and enthusiasm. So that's why I guess the environment can be very competitive. They want to succeed in their field. So in order to succeed, they want to develop a feature that go viral on TikTok. In order to develop those feature, you have to keep trying new things, working with product manager, and just doing that can create a heavily competitive environment. Yeah, I don't see any other question. Oh, wait. Any advice would you give to students who wants to pursue a career in visual arts animation? Uh, yeah, because of AI, there's a lot of uncertainty. Like I have a few like of like I have a few friends uh, whose kids are about to graduate college from art university. So I have a few friends who send their kids to Pasadena Art Center, and they are pretty concerned about AI. But what I usually tell them is like if you believe in your talent and if you are passionate about your work, then you will be able to uh, stand out from the crowd and be able to succeed in your career, even if it's like even if your major is like in painting or concept art. Because even when AI gets really good, I think you will still need that top 1% of people who are really good at in their skill. And I see that in programming as well. A lot of software engineers at TikTok, when I left, they were actually concerned about AI. But if you play with AI, then you will realize that you have to know what to ask first in order to create the things that you want to create. And if you work in a large, massive repository, AI won't be able to navigate through right away. You need a person that can be partnered with AI to work in those real world setting. So, but I do have a concern that it's going to be only like a top 1% that's going to be able to survive uh, in this world with AI keep improving. So, like I guess, yeah, I guess the advice is like be confident about your what you're working at, and if you are passionate about what you're doing, and if you and if you I guess one thing that I forgot to mention is like keep using the tools that's related to AI. Don't try to stay away from it. I don't think you will be able to avoid using AI. There's like so many tech company that are screening people based on how they are able to use the tool using that's helped with AI. So if you look at a company, like any company that's working in tech, uh, nowadays they will ask you whether you are using the tools like a Copilot or a Cursor, a lot of the tools that's developed using AI. So trying to stay up to date on the AI tools and try to keep using the tools that rely on AI so that it can help you amplify your skill. And that's how I think about AI. AI is gonna uh, make you like really efficient and amplify the skills that you have so that compared to the people who aren't able to utilize AI, you will be able to accomplish like 10 times the work that like people who aren't using AI. So yeah, continue to explore the space that is keep improving. Uh, yeah, yeah, just like be confident and try to explore a lot of the tools in AI space and continue to work on what you're passionate about. It's something that I struggle with. I have a son that's 14 years old, and I'm trying to see which field is the best field for him to work in. And yeah, I thought becoming a software engineer will be a great path for him a couple years ago, but I don't think I can give that advice to my son right now. So. Uh, AI is improving so fast, and uh, even for me, it's tough to keep up with all the news that's coming out of all the big tech company. But I think only advice I can give is continue keep using the tools, because if you don't use it, then you will uh, be left behind. So.
Okay, so do you have some more questions? I mean, on your screen, do you have any questions?
Nope, I don't see any.
Okay, so the last call. Well, if you have any questions, and then, yeah, please. No, not really. Okay, then, yeah, thank you, Domin. And then, well, always, you are so excellent. and I think it's gonna be very, very, helpful for the student. All right, and the student, and then yep, give me some, big, yep, and then we will meet next, Tuesday, and you're gonna start the real lecture. Okay, thank you so much, everybody. All right, so good night.
Bye.